Welcome back to DeFi Experts Explained. Today, one of the wildest hacks ever. Someone borrowed a fortune for about 15 seconds, used it to vote themselves the entire treasury of a protocol, and paid the loan back. All in a single transaction. No hacking, no stolen keys, they just follow the rules of a broken voting system. We'll rebuild it from scratch, drain a treasury on camera, and then fix it. Let's go. This attack needs two ingredients. First, on-chain governance. Token holders vote on proposals, and your voting power is simply how many governance tokens you hold. Second, the flash loan. A loan of any size with no collateral on one condition, that you pay it back before the transaction ends. Put them together, and the danger is obvious. If voting counts the tokens you hold right this instant, you can borrow the majority, vote, and give them straight back. This really happened. In April 2022, a stablecoin protocol called Beanstalk Farms lost around $182 million this exact way. The attacker flash borrowed a supermajority of its governance tokens, passed their own malicious proposal, and swept the funds in one transaction. We're going to build a minimal version of that same attack and run it. Before any code, let's get the trick straight, because it's easy to think voting itself steals the money. It doesn't. Picture a company where your votes equal the number of shares you hold at this exact second. Now imagine you could borrow 1 billion shares for 1 second for free, as long as you hand them back before the second is up. That's the whole attack in one transaction. Step 1. Borrow the majority of the tokens, a flash loan. Step 2. Propose. This only writes down who gets paid if the proposal passes, and the attacker writes down their own address. No money moves. Step 3. Vote. This just adds a number, your balance right now, to a counter, and the borrowed majority pushes that counter past 50%. Still no money has moved. Step 4. Execute. This is the only step that touches the money. It checks the counter, sees a majority, and sends the entire treasury to the address from step 2, the attacker. Step 5. Repay the loan. So propose chose who gets paid, vote only rigged the counter, and execute did the paying. 3 separate steps that just look like one. Let's build it in Foundry. Here's the project, a config file, a source folder for our contracts, and a test that will run the attack and check the result. Everything runs locally on your own machine against no real users and no real money. We start with a skeleton, just the shape, no logic, 4 pieces, a governance token that can hand out flash loans, the vulnerable governance, which holds the treasury and lets token holders vote, the attacker, and a fixed version of the governance that we'll come back to at the end. Every function has a comment saying what it will do and empty bodies. Now we fill them in, one contract at a time. First, the token. It tracks balances like an ERC20, and it keeps a pool of tokens it can lend. The interesting one is flash loan. It hands you the tokens, calls you back so you can use them, and then at the very end insists you've returned them. If you haven't, the whole thing reverts. That callback in the middle is where the attacker does all their damage. Now, the governance contract, and here is the bug. In its 3 functions, propose just records a proposal, an address to pay, and a vote counter starting at 0. It's writing down who gets the money if this passes. Nothing moves. Vote takes your token balance right now, this instant, and adds it to that counter. It moves no money either. It's literally a running total. And execute is the only one that pays out. If the counter is past half of all tokens, it sends the whole treasury to the address from proposer. So the treasury doesn't leave because you voted, it leaves because execute pays whoever proposed named, and the flash borrowed balance was just enough to get the counter over the line. That one word. Now counting the balance you hold this instant is what lets rented tokens pass as real votes. The attacker ties it together. Bupaun takes a flash loan of the governance token, and in the callback, while holding that borrowed majority, it does 4 things in a row. Propose a plan to send the treasury to itself, vote for it with the borrowed tokens, execute it, which drains the treasury, and finally repay the loan. Borrow, vote, take, repay, all inside one function, one transaction. Before we run anything, let's read the test. So the green check mark actually means something. Up top we pull in Foundry's test tools and the 4 contracts we just wrote. Setup runs before the test. It mints the token, 400,000 to honest holders, and a 600,000 pool the contract can lend, deploys the vulnerable governance with 100 Ether treasury inside it, and creates the attacker pointed at that governance. Then test drain is the attack itself. First it checks the treasury, really starts with 100 Ether, then it calls pawn with the whole 600,000 pool, the one called that borrows, proposes, votes, executes and repays. It logs how much the attacker walked away with, and the final line is the real claim. The attacker's balance is now the full 100 Ether. If that holds, the treasury moved in one transaction from the protocol to the attacker. Run it. The test funds the governance with 100 Ether treasury, then fires the attack. And there it is. The log reads drained to attacker 100 Ether. The treasury is empty, every last coin is now in the attacker's contract, and the flash loan was repaid. 100 Ether stolen with 0 starting capital in one transaction. Passing green means the theft succeeded exactly as designed. So how do we stop it? Here's the fixed governance, and the fix is basically one line. We record which block a proposal was created in, and execute refuses to run unless at least one block has passed since then. A flash loan lives and dies inside a single transaction in a single block. So a proposal voted on with flash borrowed tokens can never be executed, the tokens are long gone by the next block. This is the timelock idea, and real protocols also use balance snapshots for the same reason. And Zone, here's the test for the fix. It deploys the fixed governance, again with 100 Ether treasury and a fresh attacker aimed at it. The key line is expect revert. We're telling Foundry we expect the very next call to fail. Then we run the exact same attack. If the time lock does its job, pawn reverts, the whole transaction rolls back, and the last line confirms the treasury still holds all 100 Ether. So this test passes precisely when the attack does not. Same attack, now pointed at the fixed governance. The test expects it to fail, and it does. Execute the reverts on the time locks, it was true the flash loan can't be repaid, so the entire transaction rolls back. The treasury still holds its full 100 Ether. This test passing means the attack was blocked, one line, and $180 million class of exploit is closed. And this isn't only a local test. I deployed both governances to Sepolia, a real public Ethereum testnet, and fired the same attack at each. On top, the vulnerable one. The attack transaction succeeds and the treasury is drained right there on the block explorer for anyone to check. On the bottom, the fixed one. The exact same transaction fails with our time lock error, execution reverted. Same code, same attacker. One line of difference between a stolen treasury and a safe one. Quick recap. The root cause was never the flash loan. It was counting votes by a balance you can hold for a single instant. The fix is to snapshot voting power when a proposal is made, or to force a delay between proposing and executing, so borrowed, one block power is worthless. The bigger lesson runs through all of DeFi. If control can be rented by the second, it was never really control. A quick note, rebuilding this hack safely and clearly takes real work. If it helps you, the wallets are on screen and there's a Ko-fi link below. Every tip funds the next breakdown. Thank you. That's the flash loan governance takeover, $182 million, rebuilt and fixed in a few dozen lines. Next episode, Oracle manipulation, how faking a single price, again with a flash loan, lets you drain a protocol that trusts the wrong number. Subscribe so you don't miss it. Tell me in the comments which exploit to break down next, and I'll see you there.